Hi, today we're going over section 4.6 formulas, solving for a specific variable. In this video, we'll talk about how to solve for a variable, and we'll go over problems number 1, number 2, and number 3. When you're trying to solve equations in the real world, they have fractions and they get messy. So how do I get rid of those fractions? Multiply everything by the lowest common denominator and clear the fractions. Then you can simplify, reduce, and combine like terms on both sides of the equation. Then what if you have a couple of terms with the letter you want on one side and a term on the other side? Move all the terms with the letter you want to one side and all the other terms to the other. Then the letter you want becomes the GCF. And you factor it out, and then you can divide by what's left, and you're golden. Let's look at that process. Problem number 1. This comes from physics. The focal point of a lens F is related to P, the distance from the object to the lens, and to Q, the distance from the lens to the image, by the equation 1 over F equals 1 over P plus 1 over Q. Now, let's solve for P. I notice here is P, just one P right there in the denominator, and we're adding, and it just seems really messy. So the first thing I want to do is multiply the entire thing, or both sides of the equation, by that common denominator. F times P times Q. You need the most of each distinct prime, and so it's just F, P, and Q. All right, let's go through and distribute. So when we distribute to each term, so in the first term, the f's will divide to 1. I'm left with 1 in the numerator times PQ. That's equal to the p's divide to 1 in the next term. I'm left with 1 in the numerator and FQ. Plus, in the last term, the q's divide to 1. I'm left with the 1 in the numerator times FP. Now, this is what I was talking about. Move all the terms to one side with the letter that you're looking for. I'm looking for P, and I see two terms that have P. So I'll take them to the left. So PQ minus FP is equal to FQ. Now, how do I get P? Factor it out. See, this is our little trick for this section. Factor out that greatest common factor of P, and I'm left with Q minus F. And now I can just divide both sides by Q minus F. So P equals FQ divided by Q minus F. And we have successfully solved for P. Let's look at number 2. Planetary orbits. The formula x squared over a squared plus y squared over b squared equals 1 can be used to plot a planet's elliptical orbit of width to a and length to b. Isn't that awesome? Let's solve for b squared. Once again, I'm trying to solve for something that's in a denominator and it looks complicated, but you've got this. Clear those fractions by multiplying everything by that lowest common denominator. Remember, on the right side, 1 is the same as 1 divided by 1. 1 is the denominator. Anytime you just have one piece, you can always divide it by 1. All right, what is the LCD? A squared, B squared. So the most of each distinct prime, so A squared, B squared. And we're going to distribute that to all three pieces. Don't forget to distribute to the 1 over here. The a squareds divide, so I have x squared b squared plus, then the b squareds divide to 1, so y squared a squared, and then equals a squared b squared. Now, I want to solve for b squared, so all the pieces with b squared, I move to the left, then I can factor out a b squared and divide by what's left. So I have x squared b squared, then subtract the a squared b squared, and then move this y squared a squared to the right. So subtract the y squared a squared. Be careful with your signs. If you're moving from one side to another, make sure you have the right sign. So I subtracted the y squared a squared, subtracted the a squared b squared. Now, factor out that common term of b squared. That's what we're looking for. So take out the b squared. I'm left with x squared minus a squared. And now I can divide both sides by that. And b squared, what I'm looking for, is equal to minus y squared a squared over x squared minus a squared. Should I just divide out the a squareds? No, you can't divide unless you're multiplying. Notice I'm subtracting this a squared, so I cannot divide the a squareds. There's nothing I can do to simplify, and I'm done. Let's continue with problem number 3. Solve the formula for b. Once again, I see them twice in this denominator. So let's clean up those fractions by multiplying everything by the lowest common denominator. Notice 4 is over 1, and the lowest common denominator is b. I multiply through all 3 terms, and I get the b's divide, so x minus 4b equals negative 3y. Now I want b, and there's only one b. That's awesome. So I'll subtract the x to the other side. So minus 4b equals negative 3y minus x. And then I divide by negative 4. So b equals negative 3y minus x over negative 4. Look at all those negatives. Could I clean that up somehow? What if I factored out a negative in the numerator? So b equals negative 3y plus x over negative 4. Notice when I put something in possessive parentheses, now I'm multiplying the whole parenthesis by negative 1. Since I'm multiplying, I can divide. Notice the negative over the negative divides to 1. And my final answer for problem number 3 is b equals 3y plus x over 4. Great job, you guys. Keep pressing forward. We'll see you again soon.